talk about reference angles and exact values. It's really important we know our cosine and sine of the following special degree measures. Take a second, see if you can come up with the ordered pair, and we'll fill in what each of them are. Hopefully, if you guys are struggling with some of the special ones, maybe the 0, 90, the 180, the 270, you can make your ordered pair based on your 1 as a radius. Yeah. Anybody want to come up and put them on? Did they have some? You want to use smart plate? Sure. Well, you want to take a picture for yourself inside. You have to go over, or you have to go up or down. You know what I mean? So if you go over, and then you don't have to go up and down. You just kind of like the coordinate. Well, how Katie's doing that, I'm just going to write some stuff over here. So this was great. Katie's 0 degree over here. Right? You go over 1 and up 0. I love how she's got the 30 radical 3 over 2, then 1/2. Right? Remember the 30, the radical 3 has to go first. And it looks like once Katie knew the 30, to get the 60, remember we just switched the order. Okay? For 45, they're both going to be radical 2 over 2, so they're the same. Looks good. And then, nice job, Katie. So 90, way up here, we're going over 0, but you're going up 1. And then, perfect, and -1. Oh, sorry. So there's your 180, going over -1 up 0. Good. Perfect, good. So we've got 0, -1 down here at your 270. Awesome, right? Use this little thing as a help. If you guys aren't sure, a lot of you maybe like switch the signs. Maybe you had a positive one where it should have been -1, or you did a 0 first. Actually think how you would move to get to those points. That'll help you out. All this stuff is super, super important. Let's just do a quick little quadrant check. In quadrant 1, what's positive? All of them. Good. That's what the A stands for. Nice. What about quadrant 2? What's positive? Sine. Good. What else? 3? Tangent. Good. And 4? Cosine. Good. Oh, I wrote cosine. Okay. Okay. Good job. Right, so all this stuff is super important again. Okay. Today we're going to be talking about is a reference angle. You guys may have noticed on our unit circle, we had things that were bigger than just like 30, 45, and 60, right? There was angles that went all the way around. So, and I told you guys, we don't have to memorize all of them. If we knew the 3 big ones, we could get the others. And it's by something called a reference angle. What a reference angle is, it's a way that we're going to be able to tell which ordered pair to use when we're talking about larger degree measures. Basically, a reference angle is always the distance you are away from the x-axis. And I'm going to say even the shortest distance. Okay, to the x-axis. It's always an angle that's less than 90. It's got to be acute. Right? Acute thing in quadrant 1. Like this little angle right here is 60 degrees. If you're in quadrant 1, are you already acute? Yeah, you're already less than 90. So in quadrant 1, we could have just used our ordered pairs, right? It's already set for you because they're already its own reference angle. Now, once you start getting to things in quadrant 2, like if I was going to graph 120 degrees in standard position, I fall about here. Okay, what happened? Oh, like in... Oh, okay, yes, it is like a 260-degree angles, I guess. I like what you're thinking. It has something to do with that. The way you're going to figure out the reference angle is you're going to get back to the x-axis with the shortest distance. So this is like where 180 is. Oh. Okay, you're going to see what's going to be left. So if you went 120 and you're at 180. 60, good. So 60 degrees is the reference angle. You're going to figure out how much you have to get back to the x-axis. Now, if you are in the third quadrant and you graph 240 degrees in standard position, so if this is like your 240, okay, what way is going to be shorter to get to the x-axis? All the way around or back this way? Back, good. So here's your 180, and you want to figure out what's the difference between 180 and 240. 60, good. So 60 degrees is the reference angle here. If we're in quadrant 3, same idea. This one graphs, it looks like 315 degrees, way over. So here's 315. Now, to get the shortest distance back to the x-axis, it's going to be way faster to get to the x-axis that's right here, rather than going all the way back. So here's your 360 or 0. What's the difference between those? 45. So 45 degrees is going to be our reference angle. Okay. Something that might help you guys, all your reference angles should look like a bow tie. So if you're not sure which direction to go, think about it this way. If you're in quadrant 1, you're always going down. If you're in quadrant 2, we're going down to the x-axis. And 3, we have to go up to the x-axis, and same thing in quadrant 4. So you never want to go to the y-axis. You're always going back to the x. So what it ends up looking like, if you guys aren't sure, it kind of resembles like a bow tie. It just kind of might help you with direction-wise. So we're going to start out with this pretty slow. Okay? We're just going to decide what the reference angle is before we get any kind of like value. So if I look at where 100 degrees is, again, some of you guys who are visual, you really might like the picture. And if you are someone that can just figure out where you are and do the math quickly, also okay. All right, so what we're going to decide, hang on, let's grab it first. All right, if it helps you to draw in your special angle, there's your 180, there's your 270. If we graph 200 in standard position, okay, maybe somewhere over here. There's 100. Now, 100 degrees is not acute, so we need to figure out what the reference angle is. We want to go the distance to the x-axis. So the shortest distance to the x-axis is going to be this missing part. So what would this difference be here? 80. Good. So 80 degrees is going to be the reference angle. Okay.
That's annoying. You should have taken off.
No, sorry, Rita. That's how it is. Now let's do that on 260. So I'm going to graph 260. Okay. Again, if you guys need help with your angles, feel free to write them in. Here's my 270, 80, 60, 0, 90. All right, so 260, probably somewhere around here. Okay. Now, when you guys go to your x-axis, do I want to go to 360 or 180? 180, good, because this is going to be the shortest piece. So how can we figure out the difference? Subtract it. Nice, Carly. What do you think? 260 minus 180? 80. Good job. Oh, I didn't even plan that out. Sorry. So we have another 80-degree reference angle. If we take 260, we subtract your 180, the difference is going to be 80.
So if it's in the first quadrant, the angle, we can just use that as reference angle?
Yep. Exactly.
If it like overlaps with the other one?
Yeah, it should overlap.
Okay.
Yeah, it should have some kind of overlapping usually. Unless it's in like quadrant 4, then it won't.
Okay.
Yeah. Well, like if it was in this part. Okay, let's do another one here. So you guys can have that fun. Okay, so 120 degrees. Yes.
What would happen if it landed on a 90-degree
So if it's on 90 or 270, you're not going to really need to use a reference angle because you know how we could get our ordered pairs, like by doing like 0, 1,
okay.
right? And then, so those are like your quadrantal angles, the special ones. They kind of have their own properties. Good question. All right, so here's our 180, 90, 270, 0, 360. Okay, so if we graph 120, it's probably somewhere in here. Do we want to go back to 0 or to 180? 180, good. Okay, so let's figure out the difference in here. 60, 90.
If you went back to 0, what would happen?
Well, you'd have 120 degrees, right?
Oh.
So, and that's not less than 90, so it can't be. You always want to get your reference angles to be less than 90. It has to be that. Okay, so 60 degrees is our reference angle here. Why don't you guys try, oh sorry, I went the wrong direction. Why don't you guys try out the necessary? So there's your remaining answers. Check them out, see how you did. I was flipping this over. The reason why we need to have a reference angle is so we can find an exact value of bigger degrees. And that way we don't have to memorize your entire unit circle. So I wrote some steps for you guys. Right? When we're trying to find exact values of angles that are bigger than just like 30, 45, or 60, we're going to have to use our reference angle and actually kind of figure out using our ordered pairs. So our first step is to draw your angle in standard position. So for my first one, cosine 120. Okay? I'm going to make myself a little graph to get started. Okay? So 120, we're going to be somewhere over here. So there's my 120. Now, this is something that people always forget, right? We need to decide if the trig function is going to be positive or negative there. The way we do that is based on our all students take calculus, or however you guys decided to remember that. So when we're dealing with something that's a cosine, but we're in the S quadrant, is that positive or negative? Good, it's negative because only sine is going to be positive here. So I know that I need to have a negative. Okay. Now, to figure out, we don't know something special about 120. We don't have a 120 ordered pair. So what we're going to use is our reference angle. What's the difference? 60. Good. So what we're really going to figure out is going to be the negative cosine of 60 degrees. This is why your ordered pairs are going to be so important. We're going to use our 60-degree ordered pair. Okay. Who thinks they got it? Yeah, go ahead.
1/2
Awesome. And remember, cosine's the first one. So if I want the cosine of 60, yep, don't forget your negative sign, negative 1/2, because that's what the cosine is. Now, did I have to remember my whole unit circle for this? No, if you just remember the piece, you can get all of them.
Are we ever going to use the negative?
Right. Yep. Exactly. Sorry.
Are we ever going to use the unit circle?
No. That was just, I mean, like I think I told you guys, some schools have their kids literally memorize an entire unit circle. I don't know, it's almost more of a pain than, this is like the real math part of it, you know what I mean, how you would really find everything. And it's a lot less memorized, and all you need to know is like 3 ordered pairs just to get the others. Alright, so let's see, sine is 330, same deal. So we're going to draw our angle in standard position. And 330 degrees, we're somewhere way over here. I'm going to do a quick little label of my ASCC. Alright, so we are in quadrant 4, but we're talking about sine. So are we going to have something positive or negative? Good, negative. So only cosine is positive here. Talking about a sine, it's going to be something that's negative. So I really need to figure out the negative sign of, let's see, what's your reference angle? This is 360. 30, good job. Okay, so I need to use my 30-degree ordered pair for this one. So our 30 degrees is going to be radical 3/2, and then 1/2. Since we're talking about the sign here, right, make sure you're taking a second one as your sign. So actually, this one's going to be a negative, 1/2, same thing, sorry, you know. This kind of show you guys how it's all tied in together now, like the quadrants, the ordered pairs, sine, cosine, tangent, all of it kind of gets tied together. All I'm going to do one more with you guys. How do you guys try 4 and 5? Now, tangents are always a little more work sometimes. Okay, all right, 240. Way over here. Here's my 240. Here's my big STC.
So it's positive.
Yeah, nice. Because we're talking about tangent and we're in the T quadrant, we know it's going to be a positive. If you want to write the positive, you kind of remind yourself, but do you ever see a positive written? No. So, it's up to you. So, we need to do the positive tangent of, well, let's see, here's your 270, here's your 180. What's the reference angle going to be here? Nice guess, 60 degrees. Awesome. Remember, always going back to the x-axis. Let's see. Okay, so tangent, a little more work. Who knows what tangent's made up of? Oh, good. The sine of 60 over the cosine of 60. Great work. Okay, so we have to figure out the 60-degree ordered pair here. So 60 degrees, ordered pair is 1/2, then your radical 3 over 2. Okay. Remember, the sine is the second one. So when I see sine of 60, this is going to be a radical 3 over 2 divided by 1/2. So we have to use our copy, change, flip next. Can anything cancel? 2's. Oh, this is a nice one. Is radical 3 on the top or the bottom here? Top. Yeah, so it's just going to be radical 3. That's your answer. Awesome. Great when we don't have the radical on the bottom. You don't have to rationalize. So sometimes tangent is not as simple.
If it's a negative, you don't have to do like.
Oh, you're thinking of eyes. Are you thinking eyes?
There's no eyes.
Yeah, no eyes in here because your negative sign, if it was like a negative radical, it would have been on the outside part, not underneath. If it was underneath, then you have to make it a imaginary number. All right, why don't you guys take a second and see if you can try out 4 and 5. Try out 4 and 5. If anybody wants to come up, feel free. I'll walk around and give you some help. Good job with this. When you did your 150, were we positive or negative here? Negative, good. And so great reference angle of 30. So we're doing the negative cosine of 30. And our cosine of 30, use your ordered pair, it should be a radical 3 over 2. And it's going to be negative. So that I think we're done with everybody. That's good. And then your tangent, a little bit trickier. Here's your 360. Our 300 would be around here. And hey, Carly, be positive or negative?
What?
Be positive or negative from a tangent.
Oh, negative?
Negative.
I was just not thinking.
Okay. Alright, so here's your 300, and what's your reference angle? 60, but so negative tan of 60, a little bit of a pain because we need to figure out our 60 degrees and do sine over cosine. So we got the sine of 60 over the cosine of 60. Alright, so sine of 60 is going to be radical 3 over 2. The cosine is 1/2. Now if we do our little flipping, right, the 2's are going to go, we just get radical 3, but just don't forget that it needs to be a negative. How did we do with that part? Let's do good, bad, so? Okay, awesome. I got a couple little ones I wanted to show you guys. Here. You might get stuff like this, where they say, you know, find the exact value of things, and up here. Right? If you guys are asked to find the exact value, maybe do operation, all they want you to do is really just do each of these individually and add or subtract your fractions, or multiply them, whatever they're asking you guys. So if we wanted to do the sine of 225, take a second right now, see if you guys can figure out what is the exact value of the sine of 225. And you can draw your little picture. So you guys know you're dealing with a 45-degree reference angle. You're talking about the sines. Anybody know what the sine of 45 is?
Maybe radical 2 divided by radical 2.
Good job. Radical 3 over 2. You got it. I know. All those 2's. Okay, and the sine's the second one. The good thing with 45, the sine and the cosine are the same thing. So here, because of our quadrant, we have a negative radical 2 over 2. What about the tangent of 45? 1, yeah, good, because you're taking that radical 2 over 2 divided by itself, so it's just 1. Now, if you have any kind of operation work, what do we need to do when we add or subtract fractions? What do we need? Yeah. So what is this side? 2, yep. Okay. So, we have a common denominator now. This is great. But can I make this like a negative radical, like 4? Are those alike?
2 and 2.
Yeah, because we're going to kind of like keep them separate, right? They're not alike. One's in a radical and one's not. So all we can do is just actually write them together over the same denominator. No heart thing because we don't have something out in front. This one's under a radical. But if you had like a 4 here, you could do that. But usually they keep them like separate. We have time for one more, maybe? Maybe? Alright, let's try to see if you guys can do number 7. I'll pass out your homework.
A worksheet?
Yeah, it's a worksheet tonight.
You should just never do textbook with this.
I know. But like if your textbook's good with stuff, I'll use it, but if it's not like region style questions, I like to give you guys more like what you're gonna see. So alright, try this out. If anybody wants to go up and do it, ready? It looks like a lot, but it's not as bad as I think. It's just doing exactly that.
Thank you.
Alright, what do we get for the cosine of 120? Anybody know? It's going to be negative, yep, because you're in the S quadrant, which you're talking about cosine. Yep, good, we got a reference angle, 60. So our ordered pair at 60 is 1/2, and then radical 3 over 2. Which one's going to be the cosine? 1/2, good, so we have a negative 1/2 minus, oh, this is a nice one. Do we need a reference angle?
No.
No, good. We're going to use our 30-degree ordered pair. Radical 3 over 2, then 1/2. See, okay, which one's the sign? You're right.
1/2.
Good. All right, so we're going to take minus 1/2. Do we already have a common denominator? Yeah, this is great. So negative 1 minus 1 is going to be a negative 2 over what? 2. Good, which is really just? Negative 1. Awesome. Great job. You guys did awesome today. All right, so your homework's going to be this worksheet. Okay. Really try to get your ordered pairs memorized with your quadrants. All right. Can't stress how important that is. I'm going to give you guys a quiz on Friday, just in case anybody's prepping for the week, right? On like your ordered pairs, getting these exact values, where things are positive and negative. So really, you need to make flashcards, whatever you guys can do to memorize them. Make sure you try.